The first vocabulary word you need to know is the radius. It is the length of a segment that goes from the center of the circle to the edge of the circle at any point. So you can see here on this diagram, I have the radius drawn in blue, and we use R to represent the radius. The diameter is the length of a line segment, or it is the line segment itself that goes from one edge of the circle through the center to the other edge. So a diameter basically goes through the widest part of the circle. It has to go through the center. Diameter is always going to be twice as long as the radius, because if you think of it, from the center to one edge is one radius, from the center to the other edge is the other radius, so that diameter is 2 radii long. So diameter is equal to 2 times the radius. We're going to be using the radius and the diameter when we're finding our areas and our circumferences. If you have the diameter and you need the radius, you can divide it by 2. If you have the radius and you need the diameter, you can multiply by 2. So the first one we are going to learn about is the area of a circle. The area of a circle is always going to be equal to the radius squared times pi. All right, so this symbol right here is the Greek letter pi, Pi. Pi is an irrational number. That means that it never repeats and it never stops. You do not need to memorize pi, but it is approximately 3.14159. That's as far as I know for pi. That's as far as I have memorized. Your calculator has a pi button, so you can always use the pi button when we're doing these calculations. But pi is specific to circles. And what you discovered on Friday's asynchronous lesson was that as your area and circumference of your polygon, as you got more and more sides to your polygon, it got closer and closer to a circle, and the area got closer and closer to 3.14, and the circumference got closer and closer to 6.28, or twice of that length. And that's where we kind of discover pi. All right, circumference of a circle. Circumference is just the perimeter of the circle. So a circle isn't a polygon because it's really just a set of points that are the same distance from the center. So it doesn't have a perimeter necessarily, but it does have what we call a circumference. And the circumference is just the length around the edge of the circle. We can find the circumference by doing 2 times the radius times pi. Or since 2 times the radius is the diameter, you can do the diameter times pi. So that is our formula for the circumference of a circle. The easiest way to kind of understand these things is to do some examples. So let's start with this first example. Find the area of a circle. So I'm looking for the area of a circle that has a radius of 10. I am given the radius, r. I can plug that into my formula. So I would get area equals 10 squared times pi. When I'm squaring a number, I'm multiplying it by itself. So I'm going to do 10 times 10, which gives me 100 pi. You can actually leave your answer like that. This is what we call an exact answer. When we have something like 100 pi, that is the exact answer. Since pi is an irrational number, and that means it never repeats and it never stops. Anytime I get it written out as a decimal, I will have to round it, which means that it's no longer exact. It's close, but it's not exact. But I can leave it just like this, 100 pi, and that is exact. But let's see what it would be if I put it into my calculator. If I put in 100 times pi, I get this approximate answer, which is 314.159, so we'll call it 0.16. So I just rounded that decimal. And anytime you round something, it's no longer exact. Now we call it approximate. So the approximate answer is when you round it. So it has been rounded. Let's do another example. This time I am asking you to find the circumference of a circle. So I'm looking for the circumference of a circle, and I have a diameter of 7. So that means I know that D equals 7. So if I'm looking up at my formulas for the circumference of a circle, you either have it where you're given the radius or where you're given the diameter. So since I'm given the diameter, that's the one that I'm going to use. So I would say C is equal to my diameter, which is 7, times pi. That's it. There's nothing more to do. That's your answer. So this is the exact form, or the exact answer, 7 pi. If I want to find the approximate answer, I can do 7 times pi in my calculator. And my calculator tells me that the circumference would then be approximately 21.99. And I'm rounding that, which is what makes it an approximate answer. It is no longer exact, but it's close. It's just been rounded. Here's the next one we're going to find. Find the circumference. So we're looking for circumference again, but this time I have a radius of 4. So R equals 4. So when I look up at my formulas, I am going to use this one where it has R in it. So 2 times R times pi. So circumference is equal to 2 times R times pi. So 2 times 4 is 8. So 8 pi is my exact answer. If I want my approximate answer, I put 8 times pi in my calculator, and I get that it is approximately 25.1327, so that would round to 13. And there is my approximate answer. Now, what if you're given the area and you need to find a radius? So this problem, we are given the area and we need to find the radius. So find the radius of a circle with an area of 54. So this time we know that the area is 54. We want to find the radius. So I'm going to plug 54 into my formula, but it's going to go in for the left side of the equation. It's going to go in where the area is. So I'm going to say 54 equals R squared times pi. I don't know my radius, so I use R, my variable. R is being squared and it's being multiplied by pi. I need to solve this equation. I need to undo what's happening to R to get R by itself. So it is being squared, so that's an exponent, and it's being multiplied. So I do the opposite order of operations. So normally I would do exponents first and then multiply, but when I'm solving, I do it in the reverse order to kind of undo everything. That means I need to undo the multiplication first. So how you do that, it's being multiplied by pi, so I am going to divide by pi. Now, anytime I have something divided by itself, whether it's a number or a variable or an irrational number like pi, if I have something divided by itself, I get 1. So pi divided by pi is just 1. It reduces down to 1. So now the right side of my equation is 1 times r squared, or just r squared. When I'm solving an equation, if I do something to one side of the equation, I have to do the exact same thing to the other side of the equation. So I am going to do 54 divided by pi on the left side. I'm going to do that in my calculator, and it gives me 17.1887. I'm going to write all of that down for right now, and then we'll round at the very end. Okay, so now I need to get rid of the squaring. R is being squared. I need to undo squaring. The way I undo squaring is by square rooting. If I square root something squared, I'm just left with whatever was being squared. So since r was being squared, if I square root r squared, I'm just left with r. And just like everything else in solving, if I do something to the right side, I have to do the exact same thing to the left side. So now in my calculator, I'm going to square root what I had gotten before, which was 17.1887. Except in my calculator, I didn't enter the rounded number. I just pulled the answer down to make it kind of a more exact answer. And I get, 4.1459. So I'm going to round it to the hundredth. So 145. So since it's 5, I got to round it up. So 4.15 equals r. So that means my radius of this circle that has an area of 54 would have a radius of 4.15. When you round it, if you rounded earlier in your solving process, your answer might be a little bit off from what I have. As long as it's close, like within, a couple points, that's fine. If you got like 37, you did something wrong. But if you got like 4.2, that's close enough. That's okay. When it comes to doing these problems, I do not care if you leave your answer in exact form and save yourself a step, or if you put it into the calculator and get approximate form and get a decimal. It does not matter to me. I accept both forms of your answer. So that is how we find the area and the circumference of circles.